So in this video, you're going to learn how to round off values and their uncertainties to the correct number of digits. This document that you're looking at is available to you on the website. So you always round off your uncertainties first. Then you round off the values later to agree with the uncertainties. So round the uncertainties first. That's what we'll start with. So there's a rule for rounding off uncertainties, and then there's one exception to that rule, which I'll go over in a moment. So the rule is that you round uncertainties off to one significant figure, where zeros that just hold the place of the decimal point don't count as significant figures. So you round the uncertainty to one significant figure. Here's some examples. So if the uncertainty is 0.003437, then that's going to round off to 0.003, where again, the zeros that hold the place of the decimal don't count as significant figures, only the 3 does. If the uncertainty is 0.003537, then that rounds off to 0.004. So 5 or higher rounds up, 4 or less rounds down, but you keep just one significant figure on the uncertainty. So that's the rule, but remember I said that there is one exception to the rule. So let's look at that now. So the exception to the rule is when the first digit is either a 1 or a 2, because in those cases you're going to keep two significant figures rather than just one on your uncertainty. And the reason why is that if that first digit is small, then when you round off to one significant figure, you're losing too large a percentage of the information. So when the first digit's a 1 or a 2, keep two significant figures on the uncertainty rather than just one. So in the examples, you can see this. 0.001438 gets rounded up to 0.0014. So you keep two significant figures on that uncertainty because the first digit was a 1. In the second case, you've got 0.002, and again, because that first digit is a 1 or a 2, you're going to keep two significant figures, which means you actually pad the end of it with a 0, so it becomes 0.0020. So now we've covered how to round off uncertainties. Next, we talk about how to round off the values to agree with their uncertainties. The way that we round off the value is that we round it to have the same number of decimal places as the uncertainty has. So in this example, the uncertainty has been rounded to 0.04. That's 2 decimal places. That means that the value has to also be rounded off to 2 decimal places. So we would round this to 9.85 plus or minus 0.04. And the reason why is that the 4 in this example marks the digit that we're uncertain about. So if we're already uncertain about the 5 in 9.85, there's no point in writing any digits that come after it, and that's why we round it off. So you round off the uncertainty first, and then you round off the value to have the same number of decimal places as the uncertainty does. So looking at the examples down below, in the first one, the uncertainty has 3 decimal places, 0.005. That means we round off the final answer to have 3 decimal places as well. So it becomes 0.474, and again, 5 or higher rounds up, 4 or less rounds down. In the second case, the uncertainty has 3 decimal places, 0.003. That means they have to pad the end of the value with zeros to make it 1.200, so that it also has 3 decimal places. In the third example, they've got scientific notation, and notice what they've done here. They've taken the value and its uncertainty, and they put them both in brackets and multiplied them by the same scaling factor, so by the same factor of times 10 to the power of 3. I really recommend that you do this too, because if you put the value and its uncertainty multiplied by different scaling factors, that is multiplied by different times 10 to the power of factors, then it becomes really hard to see how to round them off to agree with one another. So again, I strongly recommend that you always write scientific notation this way, with the value and its uncertainty right side by side, inside brackets, and then both multiplied by the same scaling factor of times 10 to the power of whatever. Again, inside the brackets, you can see that the uncertainty is 0.04. That's 2 decimal places. Therefore, the answer also gets rounded off to 2 decimal places, 7.34. If they were multiplied by different scaling factors, it would not be straightforward to see that. So in summary, when you're rounding off values, you round the uncertainty first, you round it to one significant figure, unless the first digit is a 1 or a 2, in which case you keep 2 significant figures. Then you count up how many decimal places that uncertainty has, and you round your value to have the same number of decimal places. And one final note is that in this course, you only need to round off values in the results and discussion sections of your typed report. So you do not need to round them off in your raw data. You can leave things to the wrong number of significant figures when it's raw data. And also, Excel does a really bad job of trying to round off values, so never try to force Excel to round things off. So you only need to round off values in the results and discussion sections of your typed report. But in those sections, it is required that you round things off correctly.